In this segment I'll show you an algorithm for a more complicated problem, and the problem is to decide whether a word is a palindrome. And in case you don't know, a palindrome is a word that spells the same forward and backwards. So here we have the word deed, D-E-E-D, and if we read it from back to the front, D-E-E-D, it is the same. So this is a palindrome. The same holds for a race car, race car. If we read it backwards, race car. So this is also a palindrome. Let's check. What about record car? Fantasy words for me. No, this is not a palindrome. So our task is to write an algorithm which prints for a word whether it's a palindrome or not. How can we tackle this problem? Well, the idea is that we have a look at the letters on the outside and we compare these. So of course the first letter of the word must be the same as the last letter, and if we ignore these two, we must also look at the letters that are the second and the last but one. So what we can do is just compare the first letter and the last letter, and if they're the same, we throw them away, and then we have the same problem. We must look if the remaining word is a palindrome. So the idea is that we assume at the beginning that the word is a palindrome, and we search for evidence that it is not a palindrome. And if we cannot find that evidence, then we know it's a palindrome. And if we find two letters that are not the same, then we can stop. We don't have to search further. Then we know, okay, this is not a palindrome. And how do we know that we can stop? Well, if there are no letters left, of course, because now I started with crossing out these two, and then I compare E and E. They're the same, so we cross out these, and there are no letters left, so we are ready and we know it's a palindrome. In this case, with this word deed, we only had 4 letters, so that's an even number. But here with this word race car, this has 7 letters, so that's an odd number. What happens with race car? Okay, we compare the first and the last letter, R and R, they are the same. Then we compare with the new word, the first and the last letter, A and A, they are the same. We compare the first and the last letter, C and C, they are the same. And now we have 1 letter left. So it doesn't matter what the letter is. For any case, we know this is a palindrome. So we can stop. We know that we have a palindrome when the word has 0 or 1 letters. Now you can see how I solved this, how I translated this approach to an algorithm in pseudocode. So I call this algorithm is palindrome or palindrome check. Would also have been a nice name. And my assumption that we have a palindrome, this assumption I use a special variable to write down that assumption, and it is a variable which can only have 2 values, true or false. And our assumption at the beginning is that it is in a palindrome, so I call my variable is palindrome, and we start off by giving it the value true, because our assumption is it is a palindrome. And we will use this variable later. Now we will check the various letters of our word. Our word, as you can see, is of course the parameter of the method. And we will repeatedly compare the first and the last letter. And how often do we have to repeat this? Well, not for every letter in the word, because we have a special way of going through the word. We will not compare every letter going from left to right, but we will compare letters going from the outside to the inside. So a for each loop is not really appropriate here, so I use a while loop. And the while loop says we have to continue looking at letters while two things are true. First, we have our word length. While our word has more than one letter, we will have to continue. So as soon as we have one letter or 0 letters, our while loop must stop. And our second requirement is that we keep looking at the letters, we keep looping as long as we think that our word is a palindrome. So that's the part here, is palindrome is true. Now let's have a look at the body of the while loop. We have to compare the first and the last letter of the word, and that's exactly what I wrote down here. If the first letter of the word is the last letter of the word, well, what do we do? Well, then we just remove these and we continue. So that's what I wrote here. Remove the first and the last letter of word. Now notice that my text is a bit elaborate because I include every time words, words, and words, and that's to make sure that it is completely clear what I mean here. If I would have written if first letter is last letter, omitting of words, it might not have been completely clear to the reader what I mean. Which letter? By adding of word, it is completely clear that I refer to this variable word. So always try to be clear in what you write, even if it takes a few words or letters more. So if they are the same, we remove them and we continue. So if we have done this, our algorithm resumes, continues with and goes to end while. So we go back to the while and we check if the length is okay. What happens if they are not the same? Well, if we encounter two different letters, we know our palindrome, our word is not a palindrome. So our variable is palindrome, we give it a new value, we give it the value false. And when this happens, we can stop removing letters, we can stop doing everything, and that's what happens if is palindrome becomes false. Then our while loop here, this part, is palindrome is true, this part of the condition is becomes false, and our while loop stops. And we'll continue here. And this also is the case that we stop when the word length becomes 0 or 1. So there are two ways in that our algorithm may stop. Either we have a palindrome or it's not a palindrome. And of course that's completely reflected in our variable is palindrome. So that's what we check here. If is palindrome is true, then we know it's a palindrome, and we tell that to the user, show that the word is palindrome. Otherwise we know it's not a palindrome, so we tell the user it's not a palindrome. Now these are straightforward or easy case of palindromes, you may even make complete sentences that are palindromes. For instance, never, odd, or even. This complete sentence is a palindrome. Let's check it. Never, odd, or even. But now we not only have letters but also have spaces, and as you can see we have to ignore the spaces, and in some palindrome sentences also have colons or question marks or commas. So if we want to take that into account, we have to expand our algorithm. It's not much, we have to add only a few if statements, and I'll leave it to you as an exercise to change my algorithm to take into account complete sentences.